Welcome to part 2 of chapter 1.3 notes over distance and midpoints. Now example 2 tells us to find the distance between point A and point B. Point A is at 4, 2 and B is at negative 6, 4. Now since we are finding the distance between 2 points, we are going to use the distance formula. Now remember, the distance formula is D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. And the square root goes all the way across all of that. Now we are just going to plug in our points. x1 in this case is going to be 4 from A, so that's the first x we have. So distance is equal to square root of 4 minus now the x value in B, which is negative 6. And then we are going to square all of that plus y1 minus y2. So the y value in the first point is 2 minus the y value in the second point, which is 4. And we are going to square all of that. Now, 4 minus negative 6, that is 10. So that's the square root of 10 squared. Now remember, we need to make sure that we add the square root the entire way through. We can't just get rid of it. So this is 10 squared plus 2 minus 4, which is negative 2, all squared, which is equal to the square root of 100 plus 4. And then we get a final answer of square root of 104. Now, if we were to just leave it in the square root, just like this, square root of 104, this is what we call an exact solution. So we're actually going to write that down. This is an exact solution. Now, if we were to actually take the square root of 104 and use our calculator, which we get an answer of 10.2, this is called an approximate solution. The reasoning it's called approximate is because the square root of 104 goes on forever, whereas 10.2 is just a rounded answer of that. Now, what this tells us to do is we need to check to see, is this true? Is square root of 104 the correct answer for example 2? Now it tells us to graph the ordered pairs and check by using the Pythagorean's theorem. Now remember, Pythagorean's theorem is a squared plus b squared equals c squared. That's something that you guys should have learned in 8th grade, or if not, algebra. Now, we need to graph the ordered pairs. So the ordered pair for A is 4, 2. So that's A right there. And then the second point is B, which is negative 6, 4. So negative 6 up 4. Now what we're going to do is we're just going to connect those two, and that's called a segment when we just connect the two dots. Now, for a Pythagorean theorem, which is something that we will learn in the second semester more about, you need to have a right triangle, or the points where they come together at a 90-degree angle. Now, what we're going to do is we are going to count from B, which is the y values from 4 to 2, and then we are also going to do the points from negative 6 to 4. Now, to find the distance from 2 to 4, remember we just do 4 minus 2 is 2. So this is the point, the vertical part of all this, just 2. Now, our length, so the 2 would represent our height. Now we're going to find the length. So we're going to do 4 minus negative 6. And you should get an answer, 4 plus 6 So you get a final answer, 10. Now we're going to plug those two into a squared plus b squared. Since these two are both legs and AB is a hypotenuse, 2 is going to represent A and 10 is going to represent B. So this is 2 squared plus 10 squared equals C squared. So we get an answer of 4 plus 100 is equal to C squared. We know 4 plus 100 is 104. And in order to solve for C, we just take the square root of both sides. So we get C is equal to square root of 104, which for us, this is a good check because it shows us that both these answers match up exactly. Now, the next part of our notes is going to be over the midpoint. Now, the midpoint can be simply defined as the point halfway between the endpoints of a segment. I'll say that one more time. The point halfway between the endpoints of a segment. Now, the two examples it gives us, we see that M is the midpoint of PQ. This means that M is halfway between points P and point Q. Now there's two ways we can represent this. We can represent this as the distances are equal or the segments are congruent, which these means two different things. And equals means that two numbers are equal, and the congruent sign means that two segments or two angles are the same. There's a little bit of difference there. Now, with our example, what we can say is we can say that the distance of PM is equal to the distance of MQ. Or what we can also say is that segment PM, which the segment symbol is just a line above it without arrows, is congruent to MQ. An easy relation to kind of think about this is that the distance from an endpoint to the midpoint is half the size of the total length, or vice versa. The total length is twice the length from an endpoint to the midpoint. Now please go on to part 3 of our notes.